Hey gang, so in this video we're going to look at using Desmos to help us calculate the p-value for a significance test. So I've just brought up Desmos here to show you quickly what that's going to look like, and then we're going to look at some actual data and run our own significance test. So here I've entered in a list of, and this was just a random list of numbers from 1 to 12. And then I typed in t-test, okay, because that's the test that we're going to be running, t-test, and then a, so that it takes all of my data here, and then 7. So what this is saying is I'm running a t-test where my null hypothesis is mu equals 7. And this actually gives me all 3 possible alternative hypotheses. It gives me that mu is less than 7. It gives me the probability that mu is greater than 7. And it gives me the probability that mu is not equal to 7. Okay? So we can see the probability that mu is less than 7 is about 0.09. So it's not very likely that if this is my sample up above, if A is my sample of 60 values, it's not very likely that the actual mean of the population is less than 7. There's only a 0.09 chance of that. There's a 0.91 chance that it is greater than 7. And then there's a 0.18 chance that it's not equal to 7. Okay, so sometimes we might want to look at any of these possible values. If I were to lower this to 6, let's bring it up to 8. Now, if my alternative was that the mean was less than 8, the probability of that is very small, 0.00066. Okay? So from that, I would probably conclude that my null hypothesis is incorrect, that the mean is 8. And I would have evidence that the mean is actually less than 8 because my probability is so low that of getting these rolls up here for letter A, these rolls up here, probability is so low of getting these rolls that the mean can't be 8, or most likely isn't 8. Okay? So let's look at an example of how this is going to work with some actual data. So here I have data from the Green Bay Packers 2019 season. And this is first downs, so you can see all the first downs here, and it's only their pass plays. And I'm actually going to hide some of these columns because we don't need all of this. We don't need all of this. All we're really concerned about here are the number of yards they gained. Because maybe somebody told you that the average yards gained on a pass play on first down is 5. Okay, so we're going to set up a problem here where our null hypothesis, would be that mu equals 5. Okay, our alternative hypothesis Our alternative hypothesis is that mu is either, and we could say less than 5, greater than 5, or not equal to 5. So, take a second, think about, what do you think it is? Do you think the average number of yards gained on a first down pass by the Green Bay Packers is less than 5, greater than 5, not equal to 5? I'm going to say the Packers, they're a good passing team, so I'm going to say that it is greater than 5. Okay, so that's my alternative hypothesis. Now we should probably tell people what mu is. So mu is the mean yards passing on first down for the Green Bay Packers. Okay. So there we've got our hypotheses. The null hypothesis, mu equals 5. The alternative hypothesis, mu is greater than 5. Okay. So now when we go back to our data here, we could look at all of these values, but typically you're going to take a random sample. So I'm going to take a random sample of 20 plays. Now you can see, if we scroll down to the bottom here, this goes down to 220, but we started in row 2. So it's actually 219. So there were 219 times where the Packers passed on first down. So we want a random number between 2 and 220. Okay. So I got 210 here. Now I'm going to zoom out just a little bit here so that I can copy this down. I'm going to go down to row 21 because that will give me 20 values here. And I'm just going to check and make sure that none of those random numbers are the same. Okay. One way I could do that is I could copy. So I could right click and copy. And then I could right click again and I could paste special values only. Okay. Now the random number formula is gone. And what I can do is I can highlight those values and I can go up to data and I'm going to sort my range. So I'm going to sort those values by column P from A to Z. Okay. Notice that put them in lowest to highest order, ascending order. So now it's easy to see if there are any values that are duplicates. Okay, so I can scroll down and I can see that I didn't end up with any duplicates. So that's good. So if you do have duplicates, that's fine. Just delete one of them and type in your rand between formula again to get one more random number because we want 20 unique numbers. Okay. Now what I'm going to do is I'm going to look up the number of yards gained for each one of these. So for 2 here, that's 59. So I'm just going to come over here, type in 59. Normally, I might use a formula for this. And let's go ahead and use one because that's probably going to be the easiest way to do this here. So what I'm going to actually have to do is I'm going to insert a column to the left of this. And I'm just going to type in number 2 and 3. And then I'm going to highlight those two numbers and drag that down to the bottom of my list here so that it goes down to 220. Because now what I can do is I can use what's called a VLOOKUP. So equals VLOOKUP. What do we want it to look up? We want it to look up this number right here, this 2, comma. Where do we want it to look up? We want it to look up over here in these two columns. We want it to look it up in this column, and we're going to have it report back the yards. So we need to highlight both of those columns. Okay. So that's where we're going to look for our data. And then we want it to return what's in column 2. So it's going to look in column 1. We want it to return what's in column 2. So 2. And then we can close the parentheses and hit enter. And notice it gave us 59, which is what it was supposed to give us. There's one adjustment we have to make before we can copy this down. We want to make sure that this range that we highlighted over here, this K2 to L220, doesn't change. So we're going to have to put a $sign in front of the 2 and a $sign in front of the 220. That way, when we fill this down, the 2 and the 220 will stay the same. So we just copy those down, drag that down, and now we have our 20 values. So now what I'm going to do is I'm just going to right-click and copy, or Control-C, copy those values. I'm going to come over here to Desmos, and I'm going to say A equals, and then I'm going to paste. So Control-V, or right-click and paste. So I pasted those 20 values in. And now what I'm going to do is I'm going to use that t-test. So t-test, and I'm looking at A, and then we need our null hypothesis. We said our null hypothesis was going to be that mu is greater than 5. So when I do this, I need to put A comma 5 and then close my parentheses. And I said greater than. Okay? So if I look at greater than, I got 0.26 approximately. So what that means is, if I come back here to my hypothesis test, I got a p-value of 0.26. What that means is, assuming the null is true. So assuming that the mean passing down on first down is 5 yards. So assuming that's true, there is a 26% chance that we would see our results, or more extreme, purely by chance. Okay. So 26%, that's not a small amount. Okay, so there's a good possibility that this happened purely by chance. If that's the case, so if P is greater than, and we're going to stick with that 0.05, if P is greater than 0.05, we fail to reject the null. Okay? We do not have evidence that the mean number of yards is greater than 5. Okay? Just to show you what it would look like with a little bit different example here, I'm just going to copy this, paste it down here a little bit, and I'm going to say maybe instead of 5, maybe we heard that the mean yards on passing on first down was 4. So then our null hypothesis would be that mu equals 4, and our alternative would be that mu is greater than 4. So if I come back here and I change this to be a 4, well, let's change this even further. This is called p-hacking. You don't want to do p-hacking, but I'm going to change it to 1, just to show you what this would be like. So maybe somebody said the average number of yards gained on first down from a pass play was 1. You're like, there's no way. It's got to be higher than 1. So you make an alternative that mu is greater than 1. So on Desmos here, if we do that, now we can see that our p-value for the greater than is 0.03. Okay, so we got a p-value of 0.03. So what that means is, again, that is assuming the null is true, there is a 0.03 or 3% chance that we would see our results, or more extreme, purely by chance. Okay? So if the average yards gained from a pass play on first down is actually 1, there's only a 3% chance that we would have gotten those results that we did, which suggests that the mean probably isn't 1. So in this case, since P is less than 0.05, since P is so small, our p-value is so small, we reject the null. Okay? We have evidence to conclude that the mean yards gained from passing on first down is greater than 1. Okay? So that's kind of a whirlwind tour of significance testing. I think I'm going to create one more video here going through another example to help you out.